Okay. Um, this would be a really great activity for you to try on your own because you learn more from your mistakes than you do from learning the first time. So if you just give this a go and see what you get and see what your guesses are. So it says factor any of the following that would be classified as a difference of squares. So that was a rule that we just came up with in the previous video. If it is not a difference of squares, you don't have to factor, but you should be able to explain or state why it's not a difference of squares. So see what you notice and see if you can already gauge if it's a perfect square or not. And if you don't think it is, how can you explain why not? So pause the video here, just try it, and we can go through the examples, these questions together. Okay, so is this a perfect square? Well, let's check. Does it follow? Just gonna remind ourselves that this is what we're looking for. The a squared minus the b squared. Is it something squared? Yes. X is squared. Is it a subtraction? Yes. Is it another number squared? Yes. 9 is 3 squared. That means I can factor it. That means that I take the square root of x squared, which is x, and the square root of 9, which is 3. 1 is positive and 1 is negative, and we are done. Awesome. So we look at the second one. Let's see. Is the first one squared? Yes. Is it a difference? Subtract? Yes. Is the second one a square number? Ooh, almost. 121 is 11 squared, yes. But this guy right here is not a square number. So we can say no, x is not a squared value. I guess it's not really a number because it's a variable. So that one is not a difference of squares, but it's close, so it's tricky. All right, this one is a difference of squares, which means we can factor it, x plus 1, x minus 1. This one, yes it is. If you said yes, awesome. If you said no, why did you say no? Was it because of this 4? In fact, 4 is a square number because x to the 4 is something times itself, right? X squared times x squared is x to the 4. So yes, it can actually be square rooted. So it's a square number. So we put square here, x squared here. The square root of 81 is 9, positive 9 minus 9. Now, if you stopped here, I totally understand. You would get almost full marks. However, make sure that you always reassess to see if something can be factored again. This right here is a difference of perfect squares. So, I'm sorry, a difference of squares. I always say perfect, but that's different. So a difference of squares. So that means that the first one is not a difference because of that positive, so it just stays. Just keep it there. But the second one is a difference of squares. It is x. Oops. Let's fix this x. There we go. X plus 3, x minus 3. That is a fully factored question, and that would get full marks. Okay, the next one. No, not factorable. Why? Because this should be, it's not a difference. It's not subtraction. Okay, the next one. Yes, this is a square number. This is a square number. When we factor it, we get 3x and 5. Okay. The next one. It's a difference. We've got something squared. Well, that's really, okay, we've got something squared and another something squared. So we can factor it, absolutely. It looks weird, but it's still like x plus 5 is like the A and the x plus 2 is like the B. So if I follow our formula, we take the square root of x plus 5 squared, which is just x plus 5. So that's the first bit. We take the second bit, so the square root of x plus 2 squared, which is just x plus 2. Squish it in there. 1 is positive. I'll do it in a different color so that you can kind of see the separation between them. So one is positive, one is negative. And we're just going to clean this up because we always want to make sure that we simplify and make it into the simplest form as possible in our answers. So we have an x plus an x, gather like terms, which is 2x, 5 and a 2, which is 7. X take away x, which is just nothing. And then, oh, I forgot to mention this. When we subtract this whole thing, so there's pretend brackets in there. We could actually put brackets in this whole thing. That's probably better. Better to do that. Sometimes I forget to do brackets to show students because I just do it in my head and I don't think about that. But it's always good to put brackets if there are brackets there, especially in a question like this. So I apologize. There we go. So we've got x take away an x, and then a 5 take away a 2. So that's 0 x's and 3. You can leave it like that. That's technically correct, but in math we like to clean things up, make them really neat, and that would be the preferable way to write your answer. Okay, the next question here, is this a difference of squares? This is a square number. This is right. This is a square number. This is a difference. Square number, square number. Awesome. So yes, we can factor it. I know it's a fraction. Don't be intimidated. You can totally do this. So make my brackets bigger because of the fractions. So we have square root of x to the 4, which is x squared, right? And then over 16, so the square root of 16 is just 4, right? And just keep it like that. And then the d to the power of 4, which is d squared. We do the same thing with the 81. The 81 is 9 times 9. And then 1 is positive and 1 is negative. Did you stop here or did you keep going? Can we keep going? Remember this one up here? Do you see this below? I do. This one right here, we can factor it again because it's another difference of squares. Okay? Another thing that you can, if you're wondering, well, when do I know to check if it's another difference? Well, if this is a 4, you know that it's going to become a 2. So that's a good indication that, which is a square number, right? So that's a good indication that it's going to be able to be factored again. So we keep the first one. And then the second one, do the same thing. So we've got x over 2, and then d over 3, 1 plus, 1 minus. Now we're done. Full marks, fully factored. Good job. Okay, this bottom. Yes, square root of 100 is 10, and then square root of x is x squared, and then 36 is 6y. 1 is positive, 1 is negative. I'm staring at this again because I'm always checking to see if I can factor further, and I can factor further. I can take out a 2 out of each one. And that indicates to me if I can factor both of them, I could have common factored before I did this already. So it's okay, we made a mistake. That's why erases were made. We realized that we could have common factored first by dividing everything by 4. There we go. Now we can do our difference of squares. So it's 5x plus 3y, 5x minus 3y. Okay, this is fully factored. Again, if you did the other way, so I'm just going to show you how to get the same answer just below here. So if you did the 10x plus 6y, actually, space, and then another 10x minus 6y, you know that you could have common factored out the 2 out of each one. So this would have been 2 5x plus 3y times 2 5x minus 3y, and then the 2 times the 2 here would have become the 4. So that is another way that you could have got the same answer if you didn't realize at first. But it's always better to look for the common factor before you do that. However, you can still get to the same answer even if you realize that there was common factoring at the end. So there's 2 different ways to get to the same answer. Both will get you full marks. I'm looking for this final answer here where the common factoring is there. But it's always just better practice to start looking for the common factor before. Okay, here we go. So, is this a square number? No. Is this a square number? No. But it's a difference, yeah. Okay, so it's not a difference of squares. But can we common factor? We just spent some time talking about the importance of common factoring. They're both even numbers, so I know that 2 can go into both of them. And I think that's the biggest number that can go into those. So let's factor out a 2 and see what we get. It's hidden difference of squares. See, by common factoring out first, then you can find more factoring after. That's why I'm emphasizing in the previous question that you common factor first. Okay. Okay. I'm gonna write that in a different color. There we go. Back to this question. Now we can common factor. So we've got 3x, 5 and 5. One is positive, one is negative. You are done. This next question, is this a square number? No, but it's a subtract and it is a square number. Super close, not quite. There's not even common factoring in here, so it's not factorable. Not factorable. Well, actually, no, we're just going to leave it as a no, because this x cubed is not a square number or value. We'll change that to value. Okay, and then the last one, yes. You've gotten so good at these that you could probably start to do these in your sleep because you've done so many. These are my favorite types of factoring, by the way, because I feel like I don't really have to think. It's just like plug in the formula almost and you go. All right. Oh, we did it again. We didn't check for common factoring. And again, I just do these so much that I don't even think and I do them. And as soon as I see I could have factored out a 3 in both of them, I realized, wow, I'm not practicing what I preach. I'm not common factoring. However, mistakes are part of the process, and that is how we learn. So don't worry about it. Once you get there eventually, that's all that matters. Okay, so that is difference of squares. How to factor difference of squares while also checking for common factoring.